All right, so we are almost at the end of this track, and I did want to highlight that once API and software development governance is over, you can go into define APIs and then open API standards. Those tracks 1 and 2 are continuing. So right after this next break, you'll jump into one of those 2. For our next session, we have Rob Richardson, who is a developer advocate at Cyral. And he's talking about, he's doing a deep dive into the Git folder. Now, I had a preview into this. It is recorded because he is actually on a plane right now. So we're not yet at that bandwidth level, but it's recorded and it's an actual demo. So he's going right into code and going into Git. So I think it'll be really great. And then right after that, we'll shut this down and then go to networking. So enjoy.
Hi, welcome to the definitive deep dive into the .git folder. I'm Rob Richardson, and we're here at Interface by API Global. Let's dive in. Here's the part where I tell you I am definitely going to post the slides on my site tonight. But in this talk, there are no slides. It's only live demos. We are going to look at lots of tools, and so I have summarized the tools here on this GitHub gist. Now, you can get to this GitHub gist from the link, or head over to robrich.org, click on presentations, and here's the definitive deep dive into the .git folder, and this content is online right now. While we're here, let's click on About Me and learn about some of the things that I've done recently. I'm a developer advocate for Jetpack. I'm also a Microsoft MVP, a Docker captain, and a friend of Redgate. AZ GiveCamp is really fun. AZ GiveCamp brings volunteer developers together with charities to build free software. Hit me up on email or Twitter if you'd like to join AZ GiveCamp in Arizona, or if you'd like a GiveCamp closer to you. Some of the other things that I've done, I was a core contributor to Gulp in version 2 and version 3, and one of the things I'm particularly proud of, I replied to a .NET Rocks podcast episode. They read my comment on the air, and they sent me a mug. Woohoo! So let's dig in. Now, we want to build up a Git repository. In this case, I'm going to say Git init, where typically we might say Git clone. Now, this will create an empty repository and not link it to any servers. So this .git folder is here, and I've chosen to show hidden files and folders, which is why we see it. On Linux and Mac, files that start with a dot are hidden, and on Windows this is hidden as well, but I came in here to the few options and chose to show hidden files and folders. Now I'm going to open up the .git folder inside of VS Code, not the containing folder, because I want to be able to see the contents of the .git folder. By default, VS Code will hide it for us. Now here inside the .git folder, we can see all of the contents that we have. Did I grab that folder incorrectly? .git. There we go. We have hooks, info, objects, refs, config. We're going to open up each of these files today and learn about the contents in them. So let's create some Git content. Let's echo file1 contents into file1.txt. We will add that, git add file1, git commit-m, file1, commit message. Okay, we've just got that commit message. If we say git log, we can see that this is fb39ac. Now let's come back to our Git repository, and in the objects folder, we can see fb39ac. Now this is a bunch of mayhem. It is zlib compressed, but let's pop it open. Now we could use various tools. This Stack Overflow article identifies lots of tools that we can use to unzlib compress it or undeflate. Oh, that's actually not the right one. Let's go look at the correct one. Right here. Here's the Stack Overflow article that talks about all of the tools that we can use to undeflate a Git commit. Here's a Perl script. Here's OpenSSL. That's a pretty cool, interesting use case of it. I have a Node app that I wrote real quick that is called Unzipper. Now, unzipper uses the zlib library, the inflate methodology, to open the file, deflate it, and I split it by nulls so that we'll get the entire file. So let's unzipper .git /objects /fb/39. And here's the contents of that file. It has commit and 194. 194 is the number of bytes for the rest of this. And here's that commit message. Now this references a tree node, 7.2. We can see that's in the 7.2 folder. And then the rest of that commit is here. Yeah, that's how it organizes it, is the first 2 digits of the commit are the folder name, and the rest of it is the file name. So let's unzipper that one. 7.2. And we can see that this is actually double zlib compressed. Well, let's use some git commands to take a look at it. Git cat file -t for type, and we'll take a look at that one. 7262EA. It is of type tree, and we can git cat file -p, which stands for contents, 7262EA, and we see it's a tree node referencing this file with this file permissions, and here's the file name, and this blob, here's the file contents. Let's git cat file -p, there's the blob contents, the file1 contents. Excellent. So if we create another commit, git, let's echo file2 to file2.txt, git add file2, git commit -m file2. Now we've got 2 commits. Let's do this --1 line to be able to see them. Git cat file -p beda142, and we can see the contents there. Now this has a parent node, it also has a tree node, and navigating through each of those can be a little weird. So I've written this program called Git Explorer that allows us to view not just the commits, but also the other things, the trees and blobs. So if we show the type, here's those. So here's one commit, here's the other commit. Let's put it in alphabetical order and show the tags. So here's our new commit. It references this tree node, 2b. Here's that tree node, and it references these 2 files, 84d5. Here's 84d5, file 1. It also references file 2, 6c. So here's blob 2. And this commit has a parent node of fb. Well, let's put it not in alphabetical order, but in parent-child order. Show the lines, show the tags. And we can now see that content. Now, let's commit a file. Echo file 3. We'll redirect that to file3.txt. But let's accidentally commit a secret here in file 3. So I'm going to change file 3, and I'm going to say a secret. Git add file 3, git commit -m file 3. Now, if we've got that content, well, how would we get that out? Well, we can come in here and we can modify file 3 and we can remove that secret. Git add file 3, git commit -m file 3, and we could then squash these together, but I'm going to do amend, which will squash it right in place. And so if we look at the log, we can now see that we've got that content in place. But if we refresh our tree, show the type, parent-child, show the lines, show the tags, we can see that we not only have this new commit, but we also still have this old commit that references this old tree node with this content with the secret in it. If you've committed a secret to Git, consider that secret lost and roll the keys. Don't try to squash it out. Don't try to force push. That secret is lost. Git is really good at keeping track of these things. Well, what happens if we add a file into a folder? Let's mkdir folder and echo file2 into folder /file2. Git add file2, git commit -m file. Oh, that's not there. We want to add folder /file2, git commit -m in a folder. And let's refresh again. And we can see show the type, parent child, show the line, show the tags. Here is this new commit, and it has a folder inside that working directory. Inside that folder is file 2. Now we can see how that references the original blob when we committed file 2. So we don't need another blob just to be able to amend things or to be able to store the same content twice. But let's modify a file. So let's modified here, and we will git add file 1, git commit -m, modify file 1. But before I push that, let's push refresh and see the commits that we have. Show the type, parent child, show the line, show the tags. We have staged it but not committed it. And in staging it, it already adds that blob to the repository. That way, if we change the file but don't restage it, it'll have the file at the point where we staged it. Now we commit it and refresh again, and we can see that the, parent child, show the type, show the tags. Now we can see that we've got that tree node and commit referencing that content. So that was great. We got to see the objects folder, how it stores blobs, commits, trees, and blobs, and how we can navigate through them. Now in time, that might get to be a lot of files, but they'll end up in the pack folder in time. If we were to run git gc, they would end up there right now. Now we're not going to run it yet, but we'll get to see that later. But behind the scenes, as we run many git commands, if it's been long enough or if the repository has changed enough, then it will run that on our behalf automatically. Next, let's take a look at the refs folder. Now, here, the refs folder. We have heads and tags. Here's the main branch, and it points at this commit, 6F333. Now, we've seen that before. That's just the commit of this latest piece in the tree. Git log --1 line. There we go, 6F33. And head is right here. It's the only ref not inside the refs folder. It points at refs heads main. Well, what if we create a branch? Git branch foo, and we'll create this branch on this commit right here. Oh, we created it on our main branch. That's fine. This foo branch just points at that particular commit. Well, how about tags? Git tag v0.1, and we'll do that tag on this commit. Now, if we do that, we can see the tag right there, and not there. Now we have a tag. It's in the tags folder, but it just points at that commit as well. Here's the head. It points at refs heads main. So if we were to say git checkout this particular commit, then now head no longer points at a ref, it points at a particular commit. Now it's not broken. We can still echo file 6 and redirect that to file 6.txt, git add file 6, git commit -m file 6. And if we take a look at the git log, one line, graph, decorate, --all, we can see that we can still commit. One line gets the one line, graph shows us the ASCII art here, decorate puts the branches in place, but I have a setting to do that all the time, and all will show us the other branches. So we see it still works, but it has this really scary message about we're in a detached head state. Now all that means is that it's pointing at a particular commit instead of at a branch. So if we were to say git checkout main and then do that thing, now it's difficult to get back to that commit. So now that we've gotten to see how commits work, let's see how that might work with a ref. I'm going to flip over to this other folder. It's also empty, and I'm going to say git init, but in this case I'm going to say --bear. Now that creates an empty repository but it's the contents of the .git folder, not the .git folder. So we don't have a working directory in this case. So let's add that as a remote. Git remote add origin. We could call it anything, but origin works. And I'm going to put the path to that server folder. Now we could point it to github.com or to our local, our internal repository, but that gets it done. Git push origin main. Now that we've pushed that branch into place, here on the server we can say git log, and we have all that content in place on the server. And we have a new piece right here. Let's do git log -- one line -- graph -- decorate -- all. We have origin main right here. In our .git repository, we have a new folder called remotes. Inside that, an origin folder, and inside that, the main folder that tells us where we've last seen that file on the server. Excellent. So now that we've gotten to explore these tags, let's see if we can find that commit again. Now, in this case, we're going to say Git Ref Log. We look through refs and we understand how those work. So Git Ref Log allows us to tour through the history of that. Now, here's the spot where we committed that file 6, git checkout that. And if we now do a git checkout -b other branch, now we're no longer in the detached head state. Let's take a look at that log. It now has a branch pointed at it. Ref Log is great at being able to see how this works. Ref Log is stored here inside logs, inside refs, and we can take a look at where head was. It started out here and it moved here. Over time it evolved, and so this is basically what Git Ref Log is doing. We can wander through the refs of each of our branches and each of the branches on our remotes as well. So there's logs. Next, let's take a look at hooks. Hooks is great for automation. Maybe we want to lint things as we stage them or run our unit test before we commit. Now these are just shell scripts, or in this case a Perl script, and to make them work, all we'd have to do is rename it to take off the .sample. So I'm going to go grab a lot of hooks that I've got already set in place, where basically I've just renamed them to not include .hooks. And I just echo the hook name and the arguments passed to it. So now let's run some hooks. I'm going to echo file7 to file7.txt, git add file7, no hooks yet, git commit -m file7. We've got a pre-commit hook, a prepare commit message hook, a commit message hook where we might be able to modify that message. And if we say git push origin other branch, we've got a pre-push hook, which is really elegant. If you've ever deployed to Heroku or to Netlify and you see a bunch of messages after you push, that's a post-commit hook running on the server to deploy your application. That can be really excellent. Now we could use this to create all kinds of interesting automation. And now I want to share it with my team. So let me say git add.git /hooks /pre apply patch hook, git status. We can't commit our hooks directory because it's inside our .git folder. There's lots of packages that we could use. Here's Git Hooks, a package that works for Node that allows us to be able to symlink the content from our .git /hooks folder to somewhere else. Now, if we look at this cheat sheet, the GitHub gist, Git Hooks and Husky both work for Node. Pre-commit hook is a Python package, but it's also used by other communities, including the C# community. In PHP, we have Phpgit Hooks or Grum PHP. Git Hooks is a shell script, and it was also rewritten as a Go program. Or we can just set our config to move that .hooks folder to another place. Now the downside of using this config is that we can't commit this config file, so we'd have to run around and do things in other places. But for example, Git Hooks just symlinks the folder, and as you install this npm module, it sets up that symlink. So you might choose to use one of these to be able to get your hooks into a place where you can commit them to your repository. Next, let's take a look at config files. Now, we saw, here's a config file. This config file is all the details that we have set inside this repository. Actually, let's look at this exclude file first. Now, this is all the things that we may choose not to commit to our repository. Bin, obj, node modules, star.lock, .env, .venv, PyCache. This looks a lot like the .exclude folder, .git exclude file. And that's very specifically because this is a specific exclude file. But we don't want to put it here because we can't commit this file. Git status, we can see how, well, we can't commit it. Echo bin to .git ignore. And if we put this inside of a .git ignore file outside of our .git folder, now we can include all of this content and we can commit it. So let's put that content there in our .git ignore instead. Git add .git ignore and git commit -m git ignore, and now we can see all of our hooks. That's excellent automation, and we can commit that file. I would invite you to not use the exclude file because you can't commit things. Another config file is this description file. Using Git InstaWeb, this is the description of the repository in Git InstaWeb. Now, you've probably never heard of Git InstaWeb. It's a web server built into Git. It doesn't work in Windows, though. But if you've ever used GitHub or GitLab or Bitbucket, you know, those use much more sophisticated Git repositories, and thus, you probably never used the description file. Now let's talk about this config file. These are all the settings that I've set inside this repository. Here's the details of where that server is called origin. Now this overrides my global file, which is in my user-specific directory, and this overrides the system file that is in my install directory. So this one is in program files. These are all the options I chose when I installed Git. And this one, my global file that is user-specific, is all the settings that I've chosen to override since. So for example, I've used VS Code as my editor instead of VI. One of the great ways to get a random number generator is to put a junior developer inside VI and ask them to quit. So I use VS Code to avoid VI. Remember when you said git config --global user.name and set your name, and user.email and set your email? Those are those settings that come here in this .git config. Well, what if you want to, for example, have a business repository and not use your personal email? So I'll just set these settings in place, and I'll change this from robrich@robrich.org to robrich@company.com. Now, this repository, but only this repository, will use my business email. Echo file 8 to file 8.txt, git add file 8, git commit -m file 8, git log. We can see that my original ones didn't change, but my new one has the company email address instead. That's perfect. We can override other settings. So for example, in my global config, I have my merge and diff tools specified. I have autocorrect set. That's really helpful. If you ever said git stas, hey, I think you meant git stash. Let me do that for you. Also in my git config are aliases. I have my default branch set to main because Black Lives Matter. And I also have set aliases. So we've done git log --one line --graph --decorate --all. We've done that a lot today. I have git hist as an alias there. Git hist. So now I don't need to type that much. Now it would be really easy for us to create aliases to make this feel like TFS or SVN. Don't make aliases to make Git feel like something else. But if you notice that you type it a lot, then this alias might be helpful. Another thing that I often do is I'll say git, and then I'll get distracted, and I'll come back and I'll say git status. Well, I have an alias right here that does a new shell and runs the git command for that thing, which means I can also say git status, and it'll go, hey, I think you wanted to do git status, and it'll just do it. That 0.8 seconds is this autocorrect timeout right here. Autocorrect in 0.8 seconds. So we've got the global git config that is user specific that overrides the system git config from when we installed Git, and we have a repository specific config that overrides those settings. We could think of this kind of like a stained glass. The first time it's set, that's the details that we've got in here. So we got to take a look at those ones. Next, let's take a look at index. Now this is a binary file, but we can take a look at how this index file works here in this Stack Overflow article. It talks about this index file. Now it has a very specific binary format, and it's kind of ugly. If you want a program to be able to parse it that isn't in Git, Gin is an excellent one that allows you to parse that file. Or here in the Stack Overflow article as well, referenced in the GitHub gist, is Git Ls Files. So let's do that. If we do Git Ls Files, it will show us all of the files in our working directory and the current hash of those files. Now without this, we might have to go wandering through. Did it get modified in this commit? No. Did it modified in this commit? No. And so a git status would be really slow. Here's that cache of all the statuses of all the files in our working directory, so Git can just quickly hash the file and see if it's changed. Because we looked for stage, here's the stage. We're not merging at the moment, so all those files are stage 0. So we got to look at this index and one other index, git gc, and now that will pack all of our objects into this pack file. Now it's zlib compressed, which makes it really small. So for example, the entire history of the Perl project, all 20 years, packed into this pack file is smaller than the checkout directory. And similar to our index here, the pack file has an index as well. So we've gotten to take a look at all of the files here inside of our Git repository. We took a look at objects and how they're stored in commits and trees and blobs. We've gotten to look at refs and see how we store branches and tags and remotes. We've gotten to look at hooks and got to see automation. We've gotten to see config files, including the local git config, the global one, and the system one. And we've got to look at other things. There are temp files like the commit edit message, and sometimes we'll end up with temp files in other places. This is just the message passed between various hooks. You can grab all of the details associated with this. Actually, let's take a look at this. Here's a description that you might want to review if you want to look deeper into each of the topics that we talked about. And my friend Eric created a really excellent infographic showing all of the different pieces inside the .git folder and how they relate. You can grab a reference to all of these things up here on this GitHub gist. And this GitHub gist is easily linked from robrich.org. Click on presentations, open the definitive deep dive into the .git folder, and you can see all of the content. In moments, I'll be at that spot where the conference has designated for a live Q&A. And if you're watching this video later, hit me up on Twitter at @rob_rich, and let's continue the conversation. Thanks for joining us here today at Interface by API Global.